Hi everyone, so this is the final lesson now on density, mass and volume problems, which means it's obviously going to be probably a little bit trickier today because it is the final lesson, so as hard as it gets basically. So this is to do where we're combining two materials or two items like to make a new either like alloy or a new material, and to work out the density of the material once you've put them together. It's a bit like the speed, distance, time. So if you're working out the density of material C, for example, when you've put these two things together, you want the total mass and the total volume. So the total mass of the two separate materials before you put them together, and the total volume of the two separate materials before you, so that you can add them up to get the total, and then you do the total mass divided by the total volume. So it's always something to bear in mind that if you've got two materials like this, we're going to need the mass and volume of A, and we're going to need the mass and the volume of B, so that then we can work out the total mass, the total volume, and work out then the density of the whole thing. So it's probably not as bad as it sounds, so let's just get started. So we've got material A and material B. So let's write down things that we know about A. So we know 377 grams, and we know the density is 5.8. So that's the mass, isn't it? 377. We know the density is 5.8. Material B, what do we know about that? Well, we know it's 1.64 kilograms. So we just have to be careful that that's kilograms rather than grams. And we know the density is the density is 4.1, so I was looking at the wrong bit. So 4.1 grams per centimetres cubed. So first thing I'm going to do is I can see the density is in grams here, and that's in kilograms, and obviously it's all in grams over there. So let's change this into grams. So there's 1,000 grams in a kilogram, so I'm going to times it by 1,000, so I get 1,640 grams. So now it's all in the same units, which is good. So the next thing then is to work out the total mass. That's nice and easy because I can see this one is 377 and this one is 1,640. So total mass, that's nice and easy now. So that's going to be 377 plus 1,640. So that gives me a total mass of 2,017. So thinking about the formula up here, we now know the total mass, but we don't know the total volume. So what I'm going to have to do is use the mass density formula triangle for material A. So I know the mass and I know the density, and I can use that now to work out the volume of A. So if I cover up the V, I've got mass divided by density. So it's going to be 377 divided by 5.8, and that's going to give me the volume of A. So 377 divided by 5.8, so the volume of A is 65, and I know it's centimetres cubed because I can take that from the density there. So same kind of thing here, isn't it? I know the mass of B, the density of B, but I don't know the volume of B, so we're going to use the same triangle again. Volume is mass divided by density, so I'm going to work out the volume of B, and that's going to be the mass divided by density, so 1,648 divided by 4.1, which is 400. So I now know that volume is 400. So going back to this, we've got the total mass. I can now work out the total volume, which is 65 plus 400, so 465 centimetres cubed. So now I can work out the density of the whole thing by doing the total mass divided by the total volume. So it's going to be 2017 divided by 465, so 2017 divided by 465, and I can round my answer now. It doesn't say how to round it, so it doesn't matter. So it's going to be 4.34 if I do it to two decimal places. The units, well, the mass was in grams, the volume's in centimetres cubed, so it would be grams per centimetre cubed, like that. Okay, so the next one then is to do with ice cream and milk. So let's write down those two things. So ice cream and milk. Right, what do we know about the ice cream? Well, we know the density is 0.75, so let's just make a note of that. So density is 0.75. What else do I know about the ice cream? I know this time a volume, because it's told 60 centimetres cubed. So this time I know a volume is 60 centimetres cubed. So you can see here I've got the density, volume, but I'm missing a mass. So that's probably something we're going to work out in a minute. Milk, what do we know about the milk? Well, density is 1.02. And I know again a volume of milk, don't I? So the volume is 50 centimetres cubed. Now I've got to work out the density of the whole milkshake. So I know that the density of the whole milkshake is going to be total mass divided by total volume. So you can see this time I can work out straight away the total volume. So that's going to be the 60 plus the 50. So total volume equals 110 centimetres cubed. But I need to work out the total mass. So to do that, I'm going to have to work out the mass of the ice cream and the mass of the milk. So using our triangle, I want the mass of the ice cream, so I'm going to cover up the M. And I've got to do the density times the volume. So I'm going to do 0.75 times 60, which is 45. So I know the mass is 45, and it's going to be grams, because I can see here the density is in grams per centimetres cubed. Now I'm going to do the same with the milk. So obviously I don't have to draw it all out, but just to show you what I'm doing. So I want the mass of the milk. So cover up the density times volume. So I'm going to do 1.02 times 50. So 51. So my mass of the milk is 51 grams. So now, going back to what I was trying to work out over here, we had the total volume, but we didn't have the total mass. So now I can do 45 plus 51, so 96. So total mass 96. So now make sure you just do the division the right way around. So density was what we were trying to work out, wasn't it? So density is the total mass divided by the total volume. So that I need to do the mass first. So it would be 96 divided by 110. So that is 0.87, and that's going to be grams per centimetre cubed. Okay, the final one. So the more you do of these, the kind of similar they get, really. So we've got a block of metal with volume 19 and density. That is combined with another metal. So let's call it metal 1, metal 2. So metal 1 is 19 metres cubed. And density, so let's put that volume. Density is 5,700 kilograms per metre cubed. Right, metal 2, I know the mass is 230, and I've got a volume, haven't I, as well? So volume is 4.8 metres cubed. So we've got to work out the density of the alloy, so that's just when it's being combined together with the other metal. So the density of the whole thing. So again, density of the whole thing, sorry, McDonald's M, DB. So density of the whole thing, total mass divided by total volume. Now, I know the mass of metal 2, but I don't know the mass of metal 1, so I'm going to have to work out the mass of metal 1. Total volume, well, I know again the volume of metal 2, and actually I know the volume of metal 1 as well, don't I? So that I can work out straight away. So it's up to you whether you want to work out the mass first or just work out the total volume. You might as well go for the volumes. So total volume is just going to be 19 plus 4.8. So that's 23.8 metres cubed. And total mass, like I said, we've got the mass for metal 2, we haven't got the mass for metal 1. So let's work out the mass for metal 1. So cover up the M because I'm trying to work out the mass, D times V, so I just need to times these together, so it's going to be quite a big number, isn't it? So 19 times 5,700, so there we go, 108,300. So that's going to be kilograms. Right, so now I can work out my total mass. So that's going to be 108,300 plus 230. So that's 108,000, and that's going to be 530 kilograms. And going back to the question then, so what's the density of the alloy? Well, I now know the total mass is this. And I've got to divide that by the total volume, which was 23.8. So 108,530 divided by 23.8. So that would be 4560.08. It's a density, everything was in kilograms or meters cubed, so it would be kilograms per meter cubed.